Hi everyone, good afternoon. Puneet, Narang this side. I think they already given my introduction. So I am leading, I'm part of the EY GDS and I'm leading generative AI here. Anurag is with me. Anurag, you want to introduce yourself?
Yeah. Hi everyone. This is Anurag here. I'm a senior technical lead at EY and working on generative AI. Thanks everyone.
Okay, so starting with my presentation. So you might have already, I'm sure a lot of you might have already had build your prototypes, pilots, POCs on LLMs, and everybody's doing that, right? Building flashy, pilots and POCs is easy. You see internet being filled of that, like YouTube, there's a lot of videos being posted, right? But when it comes to productionizing those LLMs based applications, there's a serious work which has to go behind to deploy them, right? Because you have to meet the business expectations of the stakeholders, and sometimes you have financial services, they have stringent requirement, right? So, statement is that it needs some serious work to get those LLM applications in production. And the other is that if this last year, I think the ChatGPT got launched and it was all about playing with LLMs and doing POC pilots last year. This year is all going to be about productionizing them because the clients are now seriously looking at, they have already done POC pilots and they're now looking at productionizing them, right? And this is what this is. I'll go to can we go to next slide? So as I've already told that when the ChatGPT was introduced and the large language was introduced last year, so a lot of people started working, and with experience, everybody now, and most of you who have started scaling up those applications into productions, you might have realized that there are a lot of work to be done, and there are a lot of challenges which started experiencing, and questions which starts coming from business on areas like specifically around your hallucinations. There's a lot of grounding issue in the models, and there's security and privacy issues because the clients want to ensure that if their data is going to the cloud, how the security is managed, how the privacy of the data is managed, right? There are a lot of considerations which start popping up, and these considerations is something that when you're interacting with the clients, you'll have to deep dive into this and solve them, right? The challenges. And some of the other issues could also be, for example, and if you're not able to solve this problem, so most of the clients, I've seen that they're hesitant in moving whatever like pilots you've done to the production because there's a lot of credibility at stake, right? And specifically if the applications are going to be deployed it is going to be deployed for end users, it is going to be used by the client's end users, right? And they don't want to put their reputation at stake because if it hallucinates or if it's not secure, it may create issues for them. So that is where you see this translates into to solve this sort of challenges. We have to work around multiple aspects, right? And what we have done here, if you see here, from our experience of working across last 1 year, we have been now trying to deploy. We have been working on many engagements, and many out of the engagements, many of them have now gone live. So based on the experience, we have put across certain points. It may not be covering all aspects, but at least we have tried covering in the limited time the key aspects that we can think through. And I will be taking you through them in one by one in the next couple of minutes. The first and the foremost important thing when you're trying to, when you are going to work on an engagement or if you're going to deliver any LLM application in production is to design properly. You might be seeing a very complex sort of diagram. I don't want to scare you because of the complexity. But what I've tried to capture here is that essence of typically what is the ecosystem involved, what are things, components that you interact with, right? What are the key considerations? And for specific use cases, you might be needing only part of that and you may not need all of them, right? And especially if you see here, when you're doing, when you're first stage, when you're architecting any application, right? The most important thing is you have to design with that. For example, you have to look at whether you're designing what is the security requirements for the clients. Are they okay to put data on the cloud and in a secure manner by putting all the controls, or are they the data is very, very confidential and they may only want it on premises, right? That is one design consideration. Second design consideration is, for example, your what sort of databases, vector database you are going to use, product selection, and you have to design your ingestion pipeline properly, because if you have not done the good amount of work in your ingestion pipeline, and if the data which is ingested is not good, it's going to create problems. For eventually if the data input is wrong, it is not good, it will have an impact on the output also. Then what sort of orchestration frameworks you select, right? And it depending upon your application, what sort of response time are you looking at? Is it going to be some real-time application where the latency requirement is very, very low, and if you are selecting a very large language model like GPT-4, because it will necessarily have some latency. So how do you manage that, right? How do you solution for that? Then if there's a PII data, what are sort of solutions you work with the client and identify, and those controls that you can put in place so that you avoid the PII data going into the cloud, right? And you manage that at your level. Then like if the latency again requirement is low, you might, and if you want to reduce your cost, optimize your cost, you might want to consider your caching in your solution, right? And then if there is a streaming data, then you have to also think through your streaming data handling, how to handle streaming data, because you might need to put queuing systems and all other systems to manage that, right? So you have to consider all of that. And then you also need to think through your operationalization, like how it's going to be operationalized, right? How do you monitor this LLMs once they go into production? And authentications, whether the client is using single sign-on, right? You have to integrate with that. So there'll be a lot of other consideration, how you're managing the Azure or AWS or whatever cloud you're using, security and RBAC and the different security layers, how you're managing that. So just before we go to the next topic, I just wanted to get a grasp of how many people, just want to check from you, how many in your experience have gone live with the production? Like, are you, like of the public audience, how many of you have really deployed any application in production and they're running in production? Can you raise your hands? Oh, great, I think I can see a lot of people here, at least 7 or 8 people. So it will make relevant for them, because once you start deploying those applications into productions, and like there are a lot of considerations will pop up, and which we're going to cover. So specifically, if you are going to designing a very scalable application, right? You have got thousands of users and you have high concurrency. Because in one of the scenarios that we designed, we had implemented it for a contact center where on an average at any point of time there were some 200 concurrent connections. And we have such a scenario where you're designing for 200, 300 concurrent connections, and you are also processing speech, etc., right? You have to think through and create, like, you have to create in a way, architect this in a way just to create a horizontal scaling, and you have to also think through latency, how to manage. For example, if you're creating an example, a voice bot, LLM, GPT-4, anyways, where a higher latency, in a voice bot, you will never be able to you cannot be a situation where the client is just waiting for the next instruction or LLM to respond back and to hear back. There can't be silence in between. So what you have to do is you have to think through, for example, you have to identify for such applications, low latency model selection you have to do, right? You might go with open source models with the lower, parameters, and you will fine tune them. You are using different techniques like quantization, compression, parallelization, etc., so that it is able to meet the latency requirements should go. And also, if when you're deploying this sort of like I told you about contact center application which we deployed, if you're doing a speech services, the speech, like for example, Azure speech or AWS speech, most of them have got concurrency limits. You can't have more than 100 concurrent connections. So if you have a 200 concurrent connections, you need to think through load balancing. You need to focus on multiple instances of speech services. Similarly, the LLM models, if you looked at Azure's model, for example, GPT-4, they have a throughput limit on how much tokens per second you can it will serve, right? If you have say 200 concurrent connections, you're going to be passing hundreds of tokens or thousands of tokens per second, and your existing limits may not be sufficient, right? Which is provided by the cloud service provider. So you will have to talk to them, and in the design factor for this that you have to request them for increasing your throughput, and maybe take a higher throughput from them, or you have to create an architecture where you focus multiple instances of LLMs across different regions and you load balance them. So all this are the design considerations that you have to think through when you are productionizing them. Similarly, I mean, if you have for example, if you are in a situation where you are integrating, you have knowledge repositories and you have to pick up content from the knowledge repositories, and you have multiple such repositories, different vendor make model, then instead of manually designing and doing an integration with those manual repositories, you might want to consider some sort of tool like the pipeline tools like Azure ADF or AWS Glue, because these sort of the pipeline tools is able to scale up your throughput and your pipeline. Second, they have a lot of inbuilt connectors already. For example, Azure ADF has got 100+ connectors, and it will allow you out of the box to connect to those connectors. So that way, your job of connecting and doing a custom work gets reduced already, so that it gives you a lot of advantage when you're productionizing them. And for streaming data, I think if you're streaming data, then again you have to think through Kafka and queuing system, because if you do not do that, because LLMs take their own sweet time, you will have your throughput of your application throwing the data is huge, but your LLM is slow in responding. You might have a mismatch and you might lose a lot of messages, right? And which you do not want in the production. You want this to be properly handled, so you will put in some queuing system, etc., to handle that. So other things, I think, okay, so I think Anurag, over to you, I think, for this part, proprietary API.
So good afternoon, everyone. Thanks for hearing us. First of all, just a early disclaimer, don't get too frightened while looking at so much text on the screen. I know, since the launch of ChatGPT, I know a lot of folks, including me, who become afraid whenever they see longer text, and they become habituated of asking summarize and detailed, concise summary of the text, right? So hopefully, I will be your ChatGPT in this session and try to provide the summary of this, all the slides that we have. But feel free to take a picture of it and make a note out of it. Thanks, everyone. So as Puneet emphasized, the opting the right and architecture by designing the LLM-based application. So in terms of that, in this slide, we are going to cover about the model selection. Model selection is one of the prime factors that actually enable, they make a very difference in terms of the architecture we choose. And in this slide, we are going to cover the aspect that we identify that enable us to choose all these architectural consideration. So one of them is about the security level. So suppose if we are going for the proprietary closed LLM models like OpenAI, Bedrock, it is always advisable to fork up your private virtual network and host all these inference endpoint of this model into your virtual private network. But for one of our client who is in banking domain, who has this huge they have all these huge security concerns about their data, what we did, we defined an architecture that actually enable us to host these open source model into their own premise or into their own client subscription network. Now, the second point about the PI masking. So if we are using the proprietary model, it is always advisable to use some masking layer on top of when you are passing to query to, if you have any confidential data with you. But obviously, in case of open source model, we may not need that masking layer because everything resides inside your network. The third point about the hallucination, this goes for the both model. You have to build some layer about, the checks around validation, some layer around your hallucination to mitigate all these risks. This goes for both models. Now the fourth point about the performance. So high complexity tasks, like you are using chatbot agent to query across multiple sources, or you are analyzing financial report. In these tasks, you might require, we go with the proprietary model because they obviously are right now the state of the art. But the low downstream tasks like classification, summarization, we observed and deployed that all this open source model, state of the open source model like Llama, Mistral, they are also giving a pretty good decent accuracy, slightly fine tuning or just deploying on the as it is. So this is about it. Okay. Now I think I can speak on behalf of everyone here that RAG is the global superstar of generative AI. Everyone heard of it, but this was not the case when it was coined back then in the start of January, I think 2022, because this somewhere was coined around like at that time. So when we started initially working on it, our clients had that apprehension about navigating prototype, RAG-based prototype to production. Their concern was around due diligence and the hallucination. So we developed a testing and iterative framework that enable us to optimize each component which is there inside this RAG architecture and enable us to give a better performance. So these are some of the key challenges that we faced. And we actually identified. So the first one goes for, we know that, and I think a lot of papers has been published like lost in the middle, like we talked about the text of the context length actually changes your model response. But, so that's where this part comes, that decide that what should be the right chunking strategy or how better you should segment your text. The second part here talks about the embedding. So when we build a prototype, we take 5 documents, make an embedding of it, store into a vector DB, and we perform a query, and our model able to retrieve this relevant document quickly. When we started to scale this solution, let's say we have 1,000, 10,000 documents, simply creating an embedding, storing it to vector DB, and searching a query may not lead to a poor retrieval. The third challenges was around which data set was, which way we should store this embedding. We should go for vector databases, we should go for vector library, or the recent talk we go for the knowledge graph. This is also an option. So we have to keep in mind that also. And some challenges around how we can evaluate this type of architecture, and how can we enhance user query by using query decomposition or multi-query retrieval. Because we know that as a human we are, always in a hurry and ask any random questions. Now, if I started to talk about the challenges that we face while going to production, I don't know, like even if I take 2-day session, I know it would not be enough. And I think those of us who have deployed this into production will be agree with that. But in this slide, I actually want to emphasize, as we are all developer, and there are great articles about what model to choose, how to do a different chunking strategy and all. I don't want to discuss about it. In this slide, I mostly emphasize on the actual challenges that we get and could get when we go into the production. So the first challenges was about the topic change. So in every typical conversational bot, we store the context summary, right? Conversational history, to make sure that whatever context answer we provide should be relevant to the context that user is talking about. What is happening in actual scenario where a user was asking randomly different topics, and the model response that was being provided could from based on the previous context. And I don't know, and if anyone of you have noticed, when you go to ChatGPT web and you ask some Python question, and the next question you ask about sorting or expelling something, it starts writing the code of Python. So this is something what happening in actual chatbot also. So we created a prompting layer that enable to detect this topic change and make sure like whatever the recent topic has been discussed over there. The second point is about, and I think every one of us who has been worked on legal domain, contracts domain, or the financial domain knows that document which are there in these domains varies and has no fixed format. And using a right chunking strategy may not be right choice of action. We have to define chunking strategy for each different format to get a better chunks and that we can pass to these models. Now the third point is about, as I was talking about in the challenges that, when we started scaling up to 1,000, 10,000 tokens, just the query was not enough, just the creating embedding was not enough, and doing the vector search was not enough. We have to, combine these multiple searching approaches like the hybrid search with re-ranking to enable us to get a better and more contextual response retrievals. Now the third point about, and I think this is very important, a lot of organizations restrict user to query from the different departments. Let's say I'm an engineer, so I can only query the document which is allow to engineer, not to HR. And this is where you have to create a scenario where you can only access enable engineer to query from this document, or the cases where like as a designation wise, I'm a senior technical lead, Puneet is a director there. So whatever policy which is based on me, I can access only these documents, not the one which is related to policy from the director level. So we have to create this, we have to add this filtering approach in metadata that enable to narrow down our search and we retrieve only these relevant documents. Now the fourth point about, and I think this comes when we deployed into the production. And this point comes when we deployed into the production and we are happy about it's working, but we have to provide up to the date answer. Our answer should be latest. So we developed this relevancy or recency score that enable us to filter the latest document, and also that enable us to filter the latest document. So this actually helps us. And also we define the data synchronization approach that ingest, keep ingesting data. If there is a change in the file, it's actually create an index again, and now we start retrieving from that index. So this is about it. Yeah. So I think these are very great points. Some of our team members actually has helped us to write them. But I'm not going to discuss about that. You can obviously read about it. I would rather prefer to give an example of one of the case study from one of the production deployment that we have done, and it was actually a very funny incident. So what happened? This is the one client, and he wanted us to develop a HR chatbot. So a human, as an employee, could come and ask any query related to HR information. So what was happening? And we actually open source it for provision it for beta testing some of their employees. So in an ideal scenario, a user will ask the HR query and he will get a response related to it. But the funny thing is was happening, and when we analyze log, we get to know that the people started asking random questions like, who is the Miss World in 2023? Like this type of question. And I think this is on a lighter note, it's different obviously. So they started asking this question. And so we identify the importance of such layers, validation layers that enable us to check if this is actually a relevant question or not. So we define this validation layer. And the second scenario was that when, so obviously as a human, if I ask Puneet about, when is my holiday or something incomplete question, even no one can answer this, right? So even ChatGPT can't answer it. So if as an employee, if I ask, when will I get my gratuity to ChatGPT? I'm a boss to ChatGPT, right? I can ask him anything. So when I ask when will I get my gratuity, so to answer this question, what this model will do, it will go across the gratuity document and answer it for you. Now it will answer that, okay, you will get your gratuity after 5 months. But later, which month and year I will get my gratuity. It will say, okay, when the date of which you joined, you will get your gratuity after 5 years. But we have this high expectation with ChatGPT that it will fly the plane on its own. So we are not satisfied with this answer. We want actual date and time. So this is an incomplete answer because ChatGPT don't know when you joined, and it has to know that this date. So we created this, prompting layer that actually validates if it's an incomplete answer or not, and what extra information it needs. And then it's again asked, okay, I know, can you tell me, which date you joined, and then it answers this. So this emphasizes two scenario emphasizes the importance of guardrail and why we need it. And I think feel free to, read all these great points which are there right now. So yeah, that's all. I will hand over to Puneet for further explanation. Thank you.
So just to contextualize what Anurag talked about, so there are certain things you can do, in respect to putting guardrails, context management, everything you can do. But what happens is that you still need to manage the client expectations, because sometimes clients, although they know ChatGPT hallucinates, they have used ChatGPT, but when it comes to production, they expect 100% accuracy, which is not, reasonable, because we all know, that underlying it is generative model. So it is one of the important perspectives also when you are deploying in production is to set right expectations with your business stakeholders. You have to tell them that on the day one, for example, if it's a 12-week or 15, 16-week deployment cycle, you have to tell them that the starting accuracy that you will get at the end of 16 weeks, whatever number of weeks that you're doing, based on your scope, will not going to be 90% or 100%, right? Your starting accuracy is always going to be, say, it could range from 50%, 60%, 65%, in some range, right? Depending upon what the data set was, how much better accuracy techniques you were able to use. But it's never going to be 90%. And it is going to be an iterative process of improvement, right? You have to work very closely with the client, their business teams, and instead of going live in one go, you have to go live on a stage-by-stage manner, and whatever are the major issues that they're highlighting, you have to fix them. And this accuracy will go up slowly, right? It will take time, right? It will not happen overnight. This is one of the important things. So this slide is talking about is another point, is one of the major points which we see most of the clients talking about is, my data is private, especially banking and FS clients say that, I have a lot of confidential data. If it's going to cloud, how, I don't want my data to, at least sensitive data, credit card data or other data to go to the cloud, right? I want to sanitize this data, right? How do we handle them? So this is one of the approaches that we have thought through, is that you do a PI masking. But PI masking also, you have to do multi-stage PI masking, because if you do a single-stage PI masking, you are going to skip through a lot of things. For example, the first layer could be your Azure or AWS or whatever cloud that they have. They also provide an APIs like language API or some APIs which are able to do basic masking of, they are able to provide like SSN, credit card, email address, phone numbers. They are able to do some bit of PI masking. In some cases, it might be sufficient, but in some cases, it may not be sufficient because, for example, one of the case studies that we are taking, there were a lot of question and answers. Like when you contact any contact center, you first go through a security layer. They ask you your mother's name and all that, right? Those sort of questions are asked. So they wanted to filter those questions because those questions were very confidential and they were asking about mother's name and other very sensitive information. So those were in the form of question and answers. Those sort of things cannot be handled by the layer 1 or whatever out of the box PI masking techniques available. So for that, you have to create either your own model using deep learning. You would train them on those particular questions that you want to do the PI masking. Or the alternate approach is you can also use an on-premises smaller LLM model and train and leverage that and custom fine-tune that or whatever you do that to identify those PI data, and then you filter them, right? So depending upon scenario, you can use different approaches. The other important thing is, most important thing is testing. If you've not done the testing before going live, you are likely putting the client reputation and also how the output will come at risk, because if it's not because if the testing is not done properly, you're going to definitely get into a lot of issues. Okay, and in typically non-AI type of traditional type of applications, the testing was simple, right? It was deterministic. You do only based on the output expected because you were doing some applications. But now the large language models, they have multiple dimensions. You need to now test them on multiple dimensions. You need to test them on sensitivity. Sensitivity is based on, because most of the models based on whatever, like for example, if you make slight changes in your prompt, and few short examples, if you're doing, for example, if you're using a few short example, if you change the prompt slightly, even 2 words or 3 words, it may have a huge impact on your accuracy because it will suddenly start giving the behavior of the model will change. So, and also different document types will have different chunks, right? So smaller documents may have chunk present, the context present in one paragraph, sometimes may be present in one page. So what you have to do is, and what we have done is that for this measuring the sensitivity, so what we did was we created a separate UI screen, and where you can ingest the documents and you can select different chunks, sizes, say 500, 700, 900, and you'll have a human who's validating, saying that, oh, this chunk size for this type of document is giving the best results sensitivity wise, and for this document type, oh, this chunk size of 500 might be best, for this one, this is best. So that gives you a good understanding of what sort of chunk sizes or chunking strategy you should use for your documents. Secondly, and then you can also, for depending on the use case, for example, you are doing a summarization, your bird score or for your rook score will be a good matrix. You'll have to get a ground truth data and validate that. And this part is going to be very, very specific to the use case, the type of data that you're going to do, right? And the other part is your stress testing is very important, because if you're going to deploy at scale, there will always be, if you're not tested them out, there'll always be issues. I mean, this is what I'm telling you from experience, because LLMs have got limitations in terms of prompt, how much throughput they can support, and they're always, most of the providers have put some rate limits. So you have to test it out. There are many tools available in the market. For example, we have used JMeter, we have used custom Python scripts. So to do the stress testing, and for example, if you want to test on 1 million transactions, or you want to check the concurrency of say 500 connections concurrent, you have to test it out and see which level there's a failure happening or there's something is breaking out. Right? Unless you identify that, in the production, if the people start coming, if that sort of load starts coming, it is going to fail, right? It's going to break down somewhere. So you can define steps, what is expected each level, and test it way thoroughly. The stress testing is very important. The other thing is your LLM benchmarking. So LLM benchmarking based on the model types, in the leaderboard, and there are like MMTU, like which there's a eval. There are a lot of such matrices and data sets available which let you evaluate models. That could also be at the starting when you're selecting the model, right? That stage also you can select it. Then apart from that, you also need to test on bias, whether the prompt output is having any bias or not. And for doing testing of the bias, there are some good data sets available. For example, there's a C4 Colossal, I think, data set, which is very universal. The other is Meta AI has got a causal conversation version 2. I think it's the latest version. So these type of data sets are very clean, and they are able to tell you age, gender-based, age-based, all this type of biases. They have a clean database. So if you match against them, it will give you whether the output of the LLM is having any bias or not. So you need to test it very extensively on that, so that you don't expose your company or production to any risk there. Then in terms of toxicity, most of the cloud service provider, for example, if you were using a ChatGPT or OpenAI or Microsoft or any version, they are now coming up with their own studio. They're coming up with the toxicity filtering score, and they have the tool, right? So you can use those tools, or there are a lot of open source tools. You can use those tools to identify, are there any toxic content which is going on, which I need to prevent, right? So you need to test it extensively on that. The last is your human in the loop testing. Human in the loop testing is very, very important, and you have to design this from the beginning, because when you are architecting this for the production, and if you are going to do a limited release to your, say, pilot users, it will typically be stage by stage approach. So if you're rolling this out for pilot, you might need to think through and create additional screens in the UI. For example, if there's chatbot, you need to create a screen for giving thumbs up, thumbs down with the detailed drop downs, where some sort of people who will be doing the initial testing will be able to capture feedback from the UI, and that will probably go to a, say, Excel or some sort of database or a SQL database, and that you will be able to analyze that and to improve the prompts. And you have to do this continuously fine-tuning till the time you get it. A lot of people do not design this in the UI, and you have to think through that. Other important thing is most of the clients, when we trying to go into production, they in the traditional AI models, they are used to confidence scores. They said, why is the LLM not giving any confidence score, right? And I would want to know the confidence score so that I can take decision whether if the confidence score is high, I will pass to my end user. Otherwise, I will not. I will stop it at that level, right? Can you do something there? Even before you go to human testing. So there are a couple of interesting papers which are published on evaluation, and I can probably give reference to that. So one of the approaches that we implemented, which worked very well for us, was that if you have one prompt, you create, based on the same topic, you create multiple versions, iterations of that, right? Multiple variations of that, and you pass it to the LLM. And then the output, you do a A/B testing and see, and give a confidence score. Because if the similar, if, for example, if asking about weather, and you can ask 10 different ways, what is the current weather, right? If all 10 of them, if out of 8 of them are giving the same answer response, which means the model confidence is high. And we have used this extensively for one of the clients to give a confidence score. And that confidence score, when it comes along with the LLM output, it helps business people, the application or the business take a very important decision on whether is it a required accuracy level for me to release to the production or not. You may require additional human in the loop check because that is definitely there, but a first cut type, this type of testing is definitely very, very helpful because it gives you business a lot of confidence that this application developed is is at least a good confidence is there, right? That I can release it to the business. And then in terms of LLMs monitoring, I think there are other considerations. I've already talked about rate limits. Once the application goes into the production, you have to monitor rate limits. You have to see whether it's compliant to the infrastructure security. You need to monitor for specific KPIs. You need to look at availability monitoring. Is LLM available or not? Is it because of the rate limits? Because it's getting impacted? Is scaling up? How will you scale this LLM operations once it goes into production? So all this you'll have to think through and design in your considerations. Specifically, you have to also think through the evaluation frameworks. So evaluation frameworks will talk about, for example, if the model was a generative model, this perplexity score, blue score, or rook score has to be there. If it is a classification model, you have to look at this sort of metrics, measuring accuracy, precision recall, precision Chef score. And if it's a ranking, if you're doing a ranking model, then these are the matrices. And a lot of frameworks are available. Like, for example, if you see Ragas, Toolens, Revel, and there are a lot of platforms which have been built by using those open source libraries, and they have combined it to create a sort of a platform or a stack. Like Langkit, Y Labs gives you for some additional cost. And then there's a Light LLM, Prompt Fuge, and there are a lot of such the libraries are there. You need to think through and evaluate those libraries, see which ones is best fit for you, so that it helps you evaluate these different aspects. And also within prompts, you need to monitor for a lot of different aspects, which I'm going to cover next slide. So for each in the LLM, if you the output, you need to match this. You have to need to look at each, like a lot of different aspects. For example, input prompt structure. You need to look at if the structure is constant, if it's changing, what is character count, what is difficult words, reading level, was my input prompt reading level okay? And then is there a jailbreak similarity? If there's a jailbreak happening, people are trying to, as you were saying, some other topic you're talking about, you should be able to detect this upfront so that if it goes into production, you upfront get to know and you can take some preventive action. Similarly, if you're detecting some pattern detection which people are trying to hack or they're trying to get across your LLMs, this sort of metrics is very important for you to know that, right? That it is something is happening, you proactively do that rather than waiting for some attack to go through and then later on you get to know. Other thing is your output structure. So output structure, you want to know if your output structure is changing. For example, your output was, answer is this, this. But tomorrow, because of the model upgrade or something, the structure changes. Your upstream application, because it was used to taking, say, JSON format or some format, this format is disturbed, the upstream application will be impacted because it will not be able to get. So you need to monitor for a structural change in the prompts, because if structure changes, your upstream application gets impacted. Then your toxicity score, your topic drift, if the topic was on X, but the topic of the LLM started giving some other topic response for the same question, you need to monitor that and you should be able to proactively take an action. Other last is your prompting version. How do you version your prompts? There are many tools now available like GitHub you can use for monitoring. Recently MLflow has come up with a library. So you need to think through what tools are you going to use for versioning your prompt so that every prompt change you do, there's some impact, right? There's changes happening. And business wants you to give a version, what was the version A, B, C, how much iterations happened, what was the impact. They need all that score, right? It's very important for you to monitor them. Okay, I think I've covered most of the aspects. So if you look at the conclusion, so I think you might have seen there's a lot of consideration from architecture to monitoring to testing, right, to scaling considerations. You have to look through multiple aspects before you go live, right? With that, I think I think our session has ended. We can open to questions, right?